All right, so let's go ahead and get started here. It's about 5 after, and I know we all have a busy schedule. So I'm pleased to have Michal here from H2O presenting sparkling water. It's exciting also to have all of you here joining us. So today, I'm Joel Horowitz. I'm the marketing head here at H2O. I'm pretty active in the community. I've been working in the big data industry for over 5 years now. Michal is a PhD from Charles University. He's been working hard on Spark and sparkling water for the last few months, and so it's exciting to see what he's put together. So one of the key things that we believe here at H2O is that time is the only non-renewable resource. So speed really does matter. So one of the things that we always think about with everything we do is how do we make people's lives easier and also make things faster to get some of your time back. So today, why we're here to hear about sparkling water. I'll tell you who we are, how we do what we do, who are some of the customers and clients that we're working with, what are the main things that we believe, and then we'll get to a demo and Q&A at the end of the talk. So what I like to do is kind of set the baseline here of why, how we view kind of the problem that we're trying to solve. So just like the physical universe, the digital universe is large and it's growing. So in essence, it's doubling, every few years, and it's actually going to be the amount of data points are actually going to be larger than the number of stars in the world by 2020, according to IDC. So if we look at how the market has been evolving with this expanding data universe, we originally saw all of the enterprise kind of on-prem databases arrive with these vendors setting up relational databases on site. That led to the industry or the product of business intelligence. So we saw these players enter the market, and just like that, we saw recently even larger databases and faster databases come onto the market with columnar storage. And that led to what I believe the reemergence of what we now consider data science. And more recently, we've observed NoSQL kind of come onto the market with players such as Hortonworks, Cloudera, MapR, AWS, and most recently Spark. So these are basically tackling this big data, emerging big data problem through multiple angles. And this is kind of where we enter the space, where we believe we're basically working with distributed systems, making the processing really, really fast to do more with your data. So why is this happening? Why is data growing at such a rate? So over the last few years, we saw the price or the cost of storage go down. So it's decreasing by half every 18 months. And we've also seen the growth of what I would consider algorithm sophistication, or the growing area of machine learning and this science evolving. So that's creating an opportunity to do a lot more with your data. And H2O is the solution that's driving that as well. So what is H2O? So H2O is an application for application developers and analysts who need scalable and fast machine learning. H2O is an open source product for analytics. Unlike traditional analytics tools, H2O provides a combination of extraordinary math and high-performance parallel architecture for unrivaled ease of use. So who are we? There's actually a team of 20 or so of us that range the spectrum of math geeks, hackers, system engineers, people who have been working in this space for quite some time. So we have a really talented team here at H2O. So we've been very active in the community. We were mentioned in the top R projects this year at the User R conference. Our own data scientist, Arno, was actually named as the Fortune Big Data All-Star this last year for his contributions to the industry. We've held over 100 meetups, and we're growing our user base due to this open source platform to well over 6,000 users, and we're still growing. As a side note, we have one of our really, really cool events coming up this next month on November 18th and 19th called H2O World. It's right here in Mountain View, California at the Computer History Museum. You can go to this page, just go to our website and go to H2O World, and you can read about our agenda and all of our speakers, and you can register there to join the fun. So H2O is really an amazing platform that's really built for speed. As we mentioned earlier, that's one of our key tenets. As I mentioned, it's open source. It uses a REST API, so it makes it highly extendable to many other interfaces and programming languages like Python, JSON, R, Scala, Tableau, and Excel. We basically have some very nice native R support. So if you're familiar with R, you can actually install our CRAN package with very little overhead. And you can take all of the things that you're familiar with in R and apply them to large data. Once you've built your models or trained your models, you can actually deploy these models into a very fast scoring engine that's scalable that we've called nano-fast scoring. And finally, we have a very sophisticated set of models that range from standard workhorse algorithms like GLM or generalized linear modeling, all the way up to deep learning, where we're doing more and more work with that each day. So the way we view this data science workflow is, in essence, you have data living all over your enterprise, or even external data maybe living on web services. And so we basically have connections that can allow you to pull that data into H2O. You can do a bit of munging, whether it's in H2O or Spark, which we'll talk about today. That's stored in HDFS, so that makes it really, really simple and scalable. Next, you essentially would want to create features and basically do feature selection before you build your model. And then you can build your model either through a programming language like Scala, or via a statistical language like R, or even through our web UI, which we'll show later. And finally, we see our customers actually deploying these models into production using a very simple deploy button, whether it's a POJO, which is a plain old Java object, or it's using the REST API. We've demonstrated our performance over and over again. We're able to do 4 billion rows in only a few seconds. And we also have a very nice feature where we do compression when you load your data into H2O, saving you on space as well as speeding up the process. So some of the key tenets that we believe are, again, that code is incomplete without community. So this is why we continue to support open source to drive innovation. The second thing is this idea of law of large numbers. So what we hear from our clients and our user base and our customers is that sampling is a problem, and so we believe that you shouldn't have to sample your data. You should be able to use all of your data to build the best models possible. And finally, we believe that at the center of machine learning and predictive analytics is really this idea of math. So every generation needs to invent its own math, and we believe that machine learning is the new SQL, or ML is the new SQL. So finally, don't take my word for it. Our customers, like Hassan from Share This, talks about how easy it was for him to deploy his model into production. It's simply creating a jar file, and then you can deploy it. That makes his life a lot easier so that he actually can create value with the models he creates and not just insight. The other person who is notable here is Antonio from Netflix, who has been able to demonstrate doing some pretty heavy-duty analysis very, very simply with H2O. And I'll leave that to you to read later. So what are some of the use cases that we see? Well, we see advertising, not only with Share This, but also with Collective, as well as Nielsen and a few others. We see them using H2O to better understand how they affect their brand, how they're able to influence conversion, how they're able to reach the customers and the audience they like. Excuse me one moment. Okay, and as well as being able to create a measurable ROI. So as Hassan mentions here, he would say it's a very elegant open source in-memory machine learning engine, and as he's tried quite a few, and so it just comes back to that ease of use idea. The second use case that we see is around fraud and risk analysis to detect when the bad guys are trying to break into things. And so this comes out in terms of shopping or e-commerce. It also arrives in terms of theft, as well as password, breaking passwords, as well as looking at people making purchases. So as Nahum here from PayPal would say, is, he has to give credit to H2O. They have a very complete way of showing which algorithm is the best. I think this is an important point because most people are comfortable and they select one algorithm, where H2O actually allows you to compare and contrast multiple models and multiple algorithms to find which one is best. And finally, this is near and dear to my heart, is we use H2O for marketing. As I'm sure you're all familiar with the famous quote from John Wanamaker, most marketers only know 50-50 of where their actually spend is going versus what's actually creating value. Here we look at what's the network that we need to be talking to and how does that purvey with your spend. Who are the target segments that you should be going after? How do you create measurable impact, and how do you predict what's likely to create measurable impact in the future? And finally, most importantly, what is the ROI on that spend? And so people like Lou from Cisco has mentioned that H2O has established a new equilibrium point for performance and accuracy and cost for statistics and machine learning. So finally, here's a selected group of customers that we are working with. As you can see, H2O is a very horizontal solution, so it basically is used for many different industries and many verticals and many different use cases. So with that, I'm going to hand over the presentation to Michal, and he's going to take us through the demo on sparkling water. So if you just hold for a moment, I'll hand that over to him, and we will continue this. Okay.
Hello everybody. Here is Michal from America, and I would like to introduce Sparkling Water, which is the integration of Spark platform with H2O. So what are the motivations to integrate these platforms? In fact, the Spark is quite popular platform in current age. So they provide, or Spark provides really nice and user-friendly API, which is quite easy to use for not only for developers but also for data scientists. They have really a large and active community, and the product is growing uh, really fast. And what is really important, they provide interesting components which are not available in H2O. For example, they provide SQL component which allows you for writing and executing distributed SQL queries. And also they, for example, provide multi-tenancy. On the other hand, in H2O, we really focus on being efficient. We are focusing on the performance of computation and performance and efficiency of data storage. We also tune our machine learning algorithms and prove that they are correct from a mathematical point of view. And we also provide some benefits. We provide a parser which is really stable and mature for parsing variety of CSV files. We provide advanced graphical user interface, and for example, most popular is R interface, which allows you to play with the distributed algorithm from the R. So there is our intention is to connect both of the worlds of the Spark and H2O to one unique way and make uh, using of both tools transparent and unique in one product. So we would like to make using RDTs, which is data structure provided by Spark, and data frame, which is data structure provided by H2O. We would like to provide an API how to mix them and use them in one product. So that's why we are providing sparkling water, and it really provides a transparent integration of the Spark and H2O because ecosystem. That means that developer can use RDDs and mix them with the H2O data frames and vice versa. So uh, developer can use H2O algorithms and input them by RDDs. In addition, Spark Motor also provide kind of type, Spark data type, which is called H2O RDD, which is a really efficient and cheap encapsulation of H2O data structures. And the most beneficial point of the Spark Motor is the transparent use of H2O algorithms, machine learning algorithms. So in this case, Spark Motor is useful for person who has already Spark workflows, but they want to call advanced machine learning algorithms, for example, deep learning or GLM or GPM. What Sparking Water does internally. So you can imagine that there is a developer or data scientist which who deals with some problem. So he implements application on the top of Sparking Water. In this case, Sparking Water serves as a library which is compiled together with the code, and then data scientists or developer use standard uh, Spark workflow and submit application to the Spark cluster. The Spark cluster contains several Spark worker nodes and master, which distribute the submitted application to the workers, and workers to execute the application creates a new JVMs, which are called executors, and execute the application. And in this point, we integrated H2O, and we share the space of the executors with the Spark. So we initialized H2O services inside the executor. This integration has several benefits since we are integrating at the same memory space as the Spark is living. We can share data structures, so we can share data with the Spark RDDs, and we can also share the infrastructure of the Spark. Another additional benefit of this integration is that we can save the space, but this is not totally true on for all the cases. Sometimes we have to do some data transfers between Spark RDBs and H2O data frames, but these are efficient, and there is a big benefit of H2O which introduce a compression of data, so we can see that the data which are stored in H2O occupies less memory than data stored in RDD, Spark RDDs. So I think this is the time for the demo. So the intention of the demo is to show simple workflow, how to use sparkling water in the context of the simple application. And the simple application is to build uh, a model using weather and flights data to predict delays of flights arriving to Chicago International Airport. So in concretely, I will load and parse data from two data sources. I will use Spark API to filter data, and then use another part of the Spark ecosystem to make a join of both data sources. Then I would like to create a regression model, use the model for operation of delays, and the last step of our workflow is to plot residual plot not from the Spark, not from the H2O, but from R. So what are the requirements of sparking water? In fact, we just need standard Linux installation or Mac OS installation and Oracle Java 1.7 or higher. You can download sparkling water from our web pages. If you go to rexdata.com/download, you'll see a section which is uh, pointing to sparkling water downloads. You can download simple zip file, unpack zip file, and you have to set up Spark Home variable, shell variable to Spark installation. Since we are not distributing Spark, we are just distributing sparkling water, and then you can start playing with the sparkling water by executing sparkling shell. And what is the sparkling shell? In fact, this is just the name for the regular spark shell, which additional parameter which just pass sparkling water classes on the command line, and that's all. From this point, you can play with the sparkling water classes. So I will switch to console and launch Sparkling Shell. So in this case, I am launching a local cluster on this machine, which contains 3 nodes. Each node has 2 computation units and 2 GB of memory. I'm using standard Spark installation. The Spark installation is the version 1.1.0, and that's all. In the next step, I will create so-called H2O content, which is in fact a connection to H2O services from the Spark context. And in this case, I will say that I will use 3 nodes, 3 H2O nodes to be executed in the Spark infrastructure. So right now I'm starting the Spark, the H2O infrastructure, and I launch 3 nodes inside the Spark JVMs. To show you that something happened in the Spark, I'm showing the regular Spark UI. You can see that there are 3 executors running on this machine, 1 driver, which is application uh, submitted by Spark Shell, and you can see that something already happened in the Spark infrastructure. And in fact, these calls, which you can see in the Spark stages UI, these calls are initializing H2O services inside the Spark. I can also go to H2O UI, which is uh, which is providing a view of the current cluster, and you can see that current H2O cluster contains 3 nodes. The point here is the whole infrastructure is running in the same JVMs as the Spark. So as the next step, I will load data. First, I will load weather data, which represent uh, weather data in the Chicago during the years. And for this case, I will use regular Spark API to load data, since data are really easy, uh, since data are really regular, so it's really easy to write the parser for that. So that's why I'm using Spark API to load them. So data are loaded. In the next step, I will just demonstrate that what are the weather data. They contain several columns about the weather information in Chicago, about the day, the temperature, and the additional conditions like snow, uh, precipitation, and degree level. And here is that the data are now running in Spark RDD. The second data source is a little bit messy. It contains the information about the flights over the US during the years. And since data are messy, I don't like to write my own parser based on the Spark API, but I will benefit from the H2O parser and use it to load data. So in this case, data will be loaded into the H2O data structure, which is called data frame, and just show you that something happened inside the H2O. I can go to H2O UI and go to the view of the data stored in H2O, and I can see that there is one table which is called all years, and it contains data about the flights over the US. This, this is one of the benefits of the integration of H2O into the Spark, that we are providing graphical UI, so you can directly explore the shape of the data which you loaded. You can see all the information about columns, about missing values, about distribution of data, and so on. So in this case, this data set contains 32 columns. There are in fact two response columns saying that something about delay, about on the time of the arrival and on the time of the departure. And there are additional columns saying the date and actual time of the flight and additional information. So the next step which I will do is to filter data. So I have all information about all flights over the US, and I would like to filter only the data, only the flights which has the destination in Chicago. So for this program, I will use regular Spark API, and I need to somehow uh, use for that H2O data structure. So in this case, I will take H2O data frame holding the flights and create a cheap wrapper around that, which will expose Spark API. This wrapper is created by the call to_rtt, which you can see on the slide. And then I will use regular Spark API. For example, in this case, I will use simple filter with the predicates filtering flight based on the destination. So I will copy this code to the console. You can see something was executed since RDDs are by nature lazy. No execution was in fact performed in the background, and we have to wait for the evaluation of the RDD. So the next step is to join both tables with the data. For this case, I will use regular Spark SQL component. I will import SQL context to the current Spark shell, register both tables as SQL tables, and then I will create a big SQL query and uh, join both tables together. So first step, initialize SQL API. So I just created SQL context and registered both tables together, and now I can create SQL query and call it. So this is the big SQL query. It in fact joined both tables based on the date of the flight and produced so-called schema RDD, which is a data structure provided by the Spark. So now I have data which are prepared for creating the model. So at this point, I'm going to the H2O API. We are providing an H2O deep learning machine learning algorithm. So what I will do, I will initialize the deep learning algorithm based on the result of SQL query. I would like to create a regression model which will predict the flight delay on the arrival and then use the model for the prediction of the delay. So first step, I will initialize the burning. At this point, it's important to say that in this case, I'm using H2O API and, and I am referencing RDDs, which are the Spark data structures. So at this point, you can see that the integration is quite transparent and you can mix both APIs as the Spark API with H2O API. And now I'm launching deep learning algorithms. It will create very simple neural network with two layers and produce the model, which is called DL model in this context. What I can do with the model, I can make the prediction. This is another example of calling H2O API. So I will call the score method on the model with the uh, result of the SQL query. I will select the prediction from the score result, and then I will use regular Spark API to collect the predicted values. So I perform the scoring of the data and collected the values. Currently, the values are just a bunch of double values which are representing the time of delay. I can also go to UI and see that there is some of the data generated. I have a data with the prediction. This is the data structure holding the predicted values. So I can even go here and see what are the predicted values. I should see also the model, but I'm not seeing the model, so I should see the at least the job which was producing the model. And what I can do with that, I can, for example, take the model and the predicted values, generate a piece of the R code, and go to R Studio and demonstrate that in this integration, in the sparkling water, I'm able to connect to H2O and call the R code from the R session. So in this case, what I will do, I will take predicted values and actual values and create a residual plot in the R Studio. And you can see very simple integration of the whole infrastructure. So I can mix Spark API with H2O API, and even I can observe data in the UI, explore data, look at the shape of the data, or even I can go to the R session and use the data to plot the results or to perform another data munching operation which I'm not able to perform in the Spark on H2O. So this is in fact the end of the demo. For the more information, you can check out our blog, Hexdata blog, which contains several Spark Note tutorials, or you can go to our YouTube channel or go to directly to the source code because all this implementation is open source. So you can check out our GitHub, look at the implementation or contribute. So thank you for your attention, and now I think it's time for questions and answers.
Yeah, thanks, Michal. That was a great presentation. So we've already had a few people writing questions in about the implementation. One of the first questions from Yao Guy was, what are the differences between the first file that you loaded into Spark and then the second file that was loaded after?
Yeah, the first file contains the weather data, and as I said, the file is regular. It's a really nice CSV file, and it's really easy to provide a parser for that. But the second file is file containing flight data over the US, and it's intentionally messy. So it contains a lot of missing values, a lot of different notion of NAs. Uh, so it's quite hard to write ad hoc parser for this kind of the file. So that's why I was switching to H2O API and using H2O parser, which we developed in fact for 2 years and tested on the millions of the lines of the customer data. So uh, we are really sure that this parser is stable and really robust. So that's why I was using two different kinds of APIs to load data.
That's great. Thanks, Michal. I think you touched on this just on a moment ago, but how many records are in the big table variable that you created? And what is the size of the training data in terms of rows that you used here?
Yeah, so I can in fact compute the count of the I can in fact compute the count of the data in the big table. In this case, I was for the demo purposes I was using only a small data set. So to be like fast with the computation. So big table, the join of the query contains 561 rows, and uh, the input data, the weather data contains, I will make a query for this. Weather table contains, you can see that I'm calling regular Spark API here for airlines table. So weather table 1461, airlines table 44,000 records. So the demo, it's intentionally small to provide a fast computation on the local machine, but even you can scale, and this demo you can provide for all the data, which in fact represent 10 gigabytes of data for the flights and another gigabyte of data for another 1 gigabyte of data for the weather.
Thanks, Michal. So I noticed that you created one model. Is it possible to, and you created one plot in R. Is it possible to show multiple models and compare them?
Yes, sure. In fact, there are possible ways to how to do that, but in H2O UI, we provide this capability to generate multiple models and compare their performance. So the model are scored, and for example, if the model is binary classifier, we can compare AUC pairs for the selected models.
Cool. And which models are actually supported in this version for sparkling water?
In this version, we are supporting deep learning, which I show in the demo, then GLM, which is generalized neural model, K-means. We have recent integration of GBM and DRF algorithms to the sparkling water, and we are working on the transferring the additional algorithms which are provided by the regular H2O version like PCA, K-means, and additional small utilities.
So is I'm getting a lot of questions about Python. So is there support for Python yet, or is there planned support for Python for sparkling water?
Currently, we are not providing Python support from the Spark point of view. We are providing our H2O Python API, which is communicating with H2O in this via the REST interface, but probably will provide later uh, Python-based API in the Spark way. So you'll be able to mix the H2O calls inside your Spark Python-based workflows.
So this is a good question. So someone asked, for the R integration or support, is there some sort of subsetting or sampling that's being done? Because in general, plotting large numbers of points will require pulling back the entire data set.
Yes, this is a very good question. So I will go to my RStudio and show you the code. In this case, our main goal for the R client is to invoke all the operations with the big data on the cloud. We never uh, pull data locally to our session. So in this case, for example, simple arithmetic operation dealing with two vectors is executed in fact on the cloud. It's never executed locally in the R session. But of course, for this example, I wanted to uh, plot data. So in this case, I asked and download data locally via the code as data frame, which will load data to the R session. But of course, in normal case, if you have large data, you have to sample. So first, you have to create a new vector in H2O by sampling, and then go to the R session and download the data to R session to plot them.
Yeah, the other alternative is you can use the H2O web UI. Another question came up about sparkling water. So, how scalable is H2O and sparkling water in general? Is it limited by memory, or how scalable? What does that look like?
Yeah, so for this case, it depends, the scalability depends on your workflow. So as I explained in the beginning, sometimes we have to do small data transfers from Spark RDBs to H2O data frame. So in this case, we will duplicate memory, which can cause some memory limits. So currently we are limited by the amount of the memory in the executor, but if you have large infrastructure with uh, enough memory, we will deal with the data quite well in H2O and communicate with the Spark. So
We ran sparkling water on AWS, right? And so, how many nodes have we tested so far?
yeah, so our typical demo scenario or testing scenario is 16 nodes, EC2 cluster with I think 16 gigabytes of memory per node, and we are running 10 gigabytes data sets to parse data and launch all our algorithms like GLM, DRF, GBM, and deburning, and we can deal in this scenario with data.
So one other question, which I think is a good one. So our data frames, or do we use data frames for H2O, and are they mutable or not mutable?
Yeah, this is one of the
And sorry, clarification. Maybe the audience wants to know what mutable even means.
okay.
Who doesn't know?
Yeah. In this case, this is big difference from the Spark one. So in the Spark, we are using RDDs, which are by notion of the RDD, by notion of the computation, immutable. So that means that you cannot change them, and you have to always create a copy. In the H2O world, we are using data frames, which are by design mutable. So you can go and mutate any location in the table, and we will handle this in the API. So this is a big difference between the Spark and H2O data structures. And the benefit of the mutability of the changing the table is really demanded by the people, by the data scientists, which who often needs to polish data and fix only the selected cells in the table. So that's why we are providing this mutable-based data frames.
So what kind of deep learning models do we have? If you can answer that, Mikhail. I know we're kind of getting into kind of the weeds a little bit, but and are there real use cases that we've applied deep learning to that we can talk about?
Yeah, for deep learning, I'm not the expert for deep learning, but uh, they are providing neural network with the back propagation. More information you can find in our deep learning vignette, which is available on our web pages, which contains machine learning description of the deep learning, and you can find all the details from the mathematical point of view. In our use cases, uh, you can find a lot of use cases in our blog page or in our YouTube channel, which contains several presentations of Arno Kendall, which is our office expert in deep learning. And what I know, he was playing with a lot of Kaggle competitions like NIST, height boson competition, African soil competition, which contains different kinds of data, different notion of data, and he was able to be in the on the top of the list in the bigger competition with our implementation of deep learning algorithm.
Thanks, Michal. So there's a couple more questions. So one more that we have is, do we have support for data integration, specifically from a relational database or elsewhere?
Yeah, currently we are supporting different data sources like HDFS, local file system, SV. We are working on SQL integration, and of course you can, for example, do SQL integration via the R that you will load the data via the R connector or via the SQL connector in R and upload the data from the R. But we will provide SQL connector soon.
Great. So is sparkling water available now, Michal, or when does it arrive?
Yeah, as I mentioned at the beginning, you can go to Hexdata download page at the address is hexdata.com/downloads, and you will be able to download the latest release of sparkling water. You can go also to the GitHub, to the Hexdata GitHub, and clone the sparkling water repository and play the sparkling water source code. So it's open source and available right now for playing.
That's great. So one last question. I don't see any more questions coming in, so I'll just ask one more. How friendly is H2O with other, machine learning libraries like MLlib and others that come up?
Yeah, the benefit, for example, of sparkling water that you can mix your analytic model with the H2O models and compare the prediction and compare the performance of the models. In H2O, we provide our own models like deep learning, GLM, GBM, DRF, PCA, K-means, and so on. And all these models or all these model builders and machine learning algorithms are written from the scratch. So we are not using any external data science or machine learning library.
So I'm getting a lot of requests actually for people who would love to play with sparkling water and use sparkling water. Do we have, are these examples? I know you mentioned a few times where you can download the package, but is there a place where people can see multiple examples of sparkling water and try some for themselves?
Yes, yes. There is at hexdata.com in the blog part. No, sorry. Blog part. There is a Spark tutorial written by Amy, and it explains all these steps which I just performed. And there are also YouTube videos showing all the workflow step by step. Or you can also go to GitHub of the Hexdata slash sparkling water, and there is GitHub-based documentation explaining now the workflows examples, and also you can go to the examples folder, and there are additional examples, and especially this example which I show during the webinar, the explanation of all these steps. And I believe all the slides will be available as well at our SlideShare account.
Yep, that's great. I will definitely upload our slides from today's session to our SlideShare. If you're not following us on Twitter, our Twitter handle's Hexadata, at Hexadata, spelled Hexadata. So you can find us there. You can also email us at support@hexadata.com if you have any other follow-up questions that we didn't get to today. With that, I'm going to wrap up the webinar because I don't see any more questions, and I'll give you 5 minutes back. I want to thank you again for joining us today here at H2O. One more friendly reminder, H2O World is next month. So if you want to learn more about sparkling water, deep learning, and our latest innovations, I encourage you to go to 0xdata.com/H, the number 20-world, to register for H2O World, and we'll see you there. Thank you so much for joining us today. I'll send out an email with this recorded video, as well as the link to the slides and the tutorial. So look out for that email and check your spam folders as well, just in case. Thanks again. And